Hello and welcome to the channel. My name is Jennifer Johnson, and in addition to raising sheep for their wool, I am an authorized Majacraft dealer. So that means I carry all their wheels, all their fiber preparation equipment like the drum carters and the flickers, spares and accessories. All the products that Majacraft offers, I carry all of them and keep them in stock here on the farm in Western New York. I'm only a Majacraft dealer, so I don't deal with any other types of spinning wheels or weaving equipment or any other manufacturers, so I'm very focused and have a pretty good understanding of the Majacraft product line. This video is about the new high-speed head from Majacraft that's specifically designed for use on the Aura spinning wheel. When Majacraft uses the word head, I'm not sure if any other manufacturer describes this part of the spinning wheel that way. What they're talking about when they talk about the head is this top part of the assembly. So the Majacraft wheels are castle wheels. And so the bobbin, flyer, pulleys are all attached to this head, and it sits at the top of the spinning wheel. I think other manufacturers use the term mother of all. So with the Majacraft spinning wheels, there's 4 wheels where you can actually remove the standard head that comes with the wheel and replace it with a head that allows you to do different things. The 4 wheels that you can interchange heads are the Aura, the Rose, the Susie, and the Susie Pro. Many times the Susie and the Susie Pro, I'll talk about them as the same wheel. So if I neglect to say Susie Pro, pretty much anything that applies to the Susie will apply to the Susie Pro. And I'm going to eliminate that qualifier of pretty much. In fact, they're identical. Aura, Susie, Majacraft Rose, and the Susie Pro, all you can get with any of them, you can get what's called an overdrive head. And that is the head that has that massive capacity bobbin, which you can load, they say, 5 liters of fiber on. It's just a massive wheel. So it's designed for production spinning. So you can make sport weight on there and just make enormous skeins. Or if you're a bulky spinner, you tend to spin on the bulky art yarn side, you can make larger skeins. You're not replacing your bobbin as frequently with the overdrive system. So that's an example of a head that you can take the standard head off and put the overdrive head on. The Rose and the Susie, for quite a while now, I've had this high-speed head option, which just allows you to spin with a faster rotation of the flyer. Really ideal for spinning lace weight yarns, or if you're trying to spin very short fibers like cotton, or some of our superfine shetland can be on the short side. So those higher ratios are really great for that type of spinning. So up until now, the Rose, the Susie, and the Susie Pro were the only wheels that you could use the high-speed head until now. So they've just come out with a high-speed head for the Aura. The reason you need different types of heads for the Aura as compared to the Rose and Susie's is the Rose and Susie's head is attached by means of pressure. So I don't know if you can see here, but there's 2 pieces to the stem that holds the head, and they're just holding it with pressure. On the Aura, on the other hand, it's held, the head is held onto the stem by use of a bolt. So it's a different assembly altogether. So you can't interchange. The high-speed head for the Aura cannot be used on the Rose and the Susie. The high-speed head on the Rose and the Susie can't be used on the Aura. And that's the same thing with the overdrive systems. They can't be interchanged because the Aura has a bolt holding the head on, and the Susie and the Rose are held on by pressure with a 2-piece stem. Now the other wheels in the Majacraft line, there's a Luna and a Little Gem, and those both have the head integral to the stem, so it's all one piece. So you can't use high-speed head or overdrive head on either the Little Gem or the Luna. Those are really more designed for just spinning those, I call them DK sport weight type yarns. You can spin very fine on both of those, Luna and the Little Gem, and you can spin bulky, but to get to those real far extremes, you have to go with the Rose, Susie, or the Aura. So the question is, what is the high-speed head for? So what the high-speed head achieves that you can't get with the standard head is just extremely high ratios. I think the Rose it's calculated to get up to 30 to 1. And what that means is your flyer is rotating really rapidly and you're getting a lot of twist immediately, like just right outside of the orifice, that twist just grabs your fiber. So that's an ideal scenario for lace weight spinning where you're not putting a lot of fibers into that twist. So you really got to make sure that it catches it rapidly so that the fiber doesn't break. Same thing with short fibers. You want that twist to get caught up immediately out of the orifice, so your fibers are bound into that twist really rapidly. I know other people that like the high-speed heads because they like to draft really fast. And so they can make a DK sport weight yarn using the high-speed head, treadling like crazy, and it doesn't look overspun or anything because they're just that adept at drafting. So that's another application for the high-speed head. But really it was designed for super, super fine lace weight yarns. So what's great about this is with the release of the high-speed head for the Aura, what they've done at Majacraft is they've just expanded the capability of your Aura wheel. So kinda, if you have an Aura wheel today, you get the high-speed head, you've kind of in a way bought a new wheel. Now, granted, you have to switch the heads out, but it's really not that difficult, and I'm going to show you that in a little bit. So it's pretty exciting for those of you that have Auras, and also for those of you that are considering an Aura, but kind of want to be able to have the Scotch Tension option. I'm going to talk about this in a second, if you're not familiar with that term. So it's really kind of groundbreaking for the Aura and fans of the Aura spinning wheel to be able to add that high-speed head to their wheel. Okay, so the next question is, how does it work? So how does this little head, this is the high-speed head, and I will put this little band on here so you can get the full effect of it. The high-speed head, compared with the Aura standard head, there's a lot of things different with it. It's smaller, it doesn't have the head flap or the tension knob over here, because with the high-speed head you're using a Scotch Tension. Again, we'll talk about that in a second. So with the high-speed head you've got two pulleys on the head in addition to the drive wheel, and what that does is it acts as an accelerator, and it multiplies the ratio of this pulley by a certain factor so that you can get to those higher ratios of 30-to-1. So let's talk about the word ratio. What does that mean when you're talking about gear mechanics as applied to a spinning wheel? So it's actually a very common term in mechanical engineering, the gear ratio. What it means is for every turn or revolution of the input wheel, and in our case that's the drive wheel. So every time the drive wheel turns one time around all the way, your pulley, and therefore your flyer in a Scotch Tension system, but your pulley rotates a certain number. Now, hand spinners know 30-to-1 means you are really twisting really fast. And 5-to-1 means it's really laid back and you're getting a very gentle twist so you can add elements and just really, bulk up your yarn. You got plenty of time to get the kind of drafting you want to get. So hand spinners recognize what those ratios are as it relates to spinning, but what it means in mechanics is just that. One turn of the drive wheel means however many turns of the pulley. And since the pulley and the flyer are attached on the same shaft, that's the rate the flyer is going to rotate around the bobbin. All right, so at the time of this video, Majacraft has yet to publish the ratios for the Aura high-speed head. So what I've done is I've done some of the work and did a very rudimentary and rough measurement of the grooves on the high-speed head and on the drive wheel of the Aura in order to be able to give you the calculation. So you can calculate a ratio, but you can also figure it out just by turning your drive wheel nice and slow and watching how many times the flyer goes around. So I think I did it where what I do is I take a little, oh, I've lost them. Oh, here we go. Take a little Post-it like this and I stick it at the top of the drive wheel and wherever, maybe at the top of my pulley. And then I'll just manually turn the drive wheel and count on the pulley how many times that goes around. And that's going to give you your ratio. So if you really want to know, that's a way that you can do it. But there is a calculation as well where you can take the diameter, well, let's do it on this one, the diameter of your pulley, which is the distance from the inside of the groove, one side to the other. So the straight across, not the circumference, but the straight across. And then the diameter of your drive wheel. You can't see it here, but It's the distance from here to here, but it's on the inside of the grooves, which are, worn into the drive wheel. So you take those two values. Let me just make sure I don't give you this wrong, because it's a little bit confusing. So when you talk about ratios on the Majacraft wheels, they say, let's just say 10 to 1. So for every 1 revolution of the drive wheel, the pulley is going to turn 10 times. So what you do is you take the diameter of the drive wheel and you divide it by the diameter of your pulley groove. These are the grooves, distance around the grooves. And the way I measured this was I took a piece of raffia, stuck it in the groove, wrapped it around on the inside of the groove to get it really accurate, and then I marked it with a Sharpie. And then I measured the distance between the two Sharpie marks, and I have to wear a headpiece because I can't see anymore. But then got that circumference, and then you just divide the circumference by pi, 3.14, to give you the diameter. And then you take the diameter of your drive wheel and divide it by the diameter of your pulley, and that is your ratio. So it's an easy calculation. So, for example, I did it on the Rose. I measured the largest groove on the drive wheel of the Rose. And the reason I picked the Rose was because Majacraft has all of their ratios on the Rose for each groove and its corresponding groove on the pulley. So I figured I would just double check to make sure I was doing it right. So I did the largest groove on the Rose drive wheel and the smallest groove on the Rose pulley, which was 55 inches and 3 inches. Divided those both by pi, and I got the diameters for the drive wheel and the pulley. I divided the drive wheel diameter by the pulley diameter and got a ratio of 19 to 1, which is really close to what Majacraft publishes on their website. I wanted to get to the diameters because it's easier to measure the pulley grooves with a caliper and get a diameter directly, and there's a lot more pulley grooves to measure than drive wheel grooves. And I don't know this stuff. I actually did a lot of research before making this video and Googled it, so chances are it's going to fall out of my head within a couple weeks. But for this video, I wanted to help those of you that maybe will be able to retain this information. The nice thing about knowing how to do the ratios, because as I said, Majacraft publishes most of the ratios for their wheels on their website. But let's just say you want to play around with stuff, and let's say you want to maybe take your pulley, take it off, and install it backwards so that the smallest groove is facing the wheel. And you want to know what those ratios are. You can calculate that, figure it out. So let's say you don't have the right pulley to get where you want to get, to make what kind of yarn you want to make. You can mess around with that, or you can adjust your pulley inward or outward so that your grooves are lined up, not per the specifications of Majacraft, but you can still use it, and you'll be able to calculate your ratios that way. Hopefully that makes sense, but it just gives you a lot more options, which is really what it's about. You want to get as many capabilities out of your wheel as you possibly can. So on your Suzy Pro, Rose, and Aura, you have multiple grooves on your drive wheel. On the Luna and the Little Gem, there's just the one groove. And so Luna and Little Gem can use all 4 of the pulleys. There's 4 different pulleys from Majacraft that you can interchange on all the wheels. And yes, that is correct. The Aura, I don't think you can use the Aura pulleys on other wheels because they actually go right into the shaft with a screw, so it's a little bit different. Although you can put the 4 pulleys on your Aura, so you do have that option. And the 4 pulleys are the slow pulley, that's also the standard on the Rose, the Little Gem pulley, the Suzy pulley, and then there's a fast pulley, which is really small, has a very, very tiny diameters, so that gives you those really fast ratios, depending on the wheel that you're using it on. So you can put those 4 pulleys on your Gem and your Luna, but your Gem and your Luna has only got the one groove on the drive wheel. Just a tiny limitation, which probably doesn't impact most people, because I hear spinners all the time telling me that, I set my wheel up and that's how it's been since I bought it, and I don't mess around with anything, which is great. I'm kind of like that, right? Because I'm only spinning the wool for my sheep and it's always going to be the same. So I get it. I'm just going to say this one more time. You are the one that sets that ratio. When you install your drive band on your pulley and your drive wheel and you select those 2 grooves, you are selecting what that ratio is. And the way it's going to work for you is the smallest groove on your pulley is going to give you the highest ratio. The largest groove on your pulley is going to give you the lowest ratio. And high ratios are more twist. It doesn't really impact the take-up tension. That's a whole other adjustment you make. But it's about how rapidly your fiber is going to get twisted before it gets wound onto the bobbin. Okay, so when I was getting ready to make this video, I wanted to be able to give you the ratios for the high-speed head on the Aura because it's not published anywhere, and I think it's a lot nicer just to have it versus having to calculate it. So what I did was I did a very rough measurement. I actually used a caliper, which is a scientific tool, and it's got a digital readout. Now, the only dilemma I had was the caliper, I don't know if I was actually hitting the base of the groove. So I think the caliper might have been getting caught up in, you know, kind of getting blocked because the groove gets narrower as it goes into the pulley. So it's possible my measurements are a little bit off. A couple times I took a piece of raffia and made, you know, did the circumference versus using the caliper to measure the diameter. Then I took the raffia and I did run it around the drive wheel to get the circumference and then calculate the diameter of the 3 grooves on the Aura drive wheel. And using that data, I still needed something else because we have this 3rd pulley on the high-speed head, which is, like I said before, it's a multiplier. So I measured this 3rd pulley. They call it the idler. And I was doing a little bit of research, and what I was reading was the idler in physics actually is what you use to change the direction of your gears. And also, when you have more than 2 gears in a system, it's called a gear train. And what that means is, like, this gear affects this gear, this set of gears then has a value that affects this gear. So it's kind of like this multiplier, like I described it before. So when I measured this idler groove, well, like I said, I measured the circumference and I came up with a diameter of a little bit more than 1 inch, which tracks. I mean, if you look at the distance of the one end to the other, it's about 1 inch. So I feel pretty comfortable I had that correct. So what you have to do is you have to get the ratio, because when the high-speed head is set up correctly, it has its own little drive band. I don't know if I told you about the parts yet, but well, I'll get to that, I think. So it has this little high-speed head drive band, it's called. And that goes in the groove of the idler, and then it goes in the largest groove of the pulley, which is where you're going to be attaching your drive band. So you actually only have 4 grooves available to you when you install this, because one of the grooves is being used to drive the idler pulley, which has the bobbin and the flyer on it. That's what this shaft is here. So as this is turning, this shaft is turning at the same rate. They're all mounted on the same shaft. So in the calculations, you have to get, when I learned this, you have to get the ratio of the 4 grooves on the high-speed head pulley aligned with the 3 grooves on the drive wheel. So I got all those values, I got all those diameters, and calculated the ratios for each of those possible grooves. So 3 grooves on the Aura, 4 grooves on the Gem. I've got every combination of those calculated in this little spreadsheet I made. But then what I had to do is I had to multiply those by this ratio, which was pulley to idler groove diameter. No, 1.8. Okay, so what that's saying is this ratio here is 2 inches diameter, was a little bit less than 2 inches. It was 1.75 in my measurements, which could be wrong, compared to this. So 2 to 1. So that's the ratio of these 2 pulleys here. So you have to multiply the ratio I got from these grooves with the drive wheel against this one, this little accelerator, so it essentially doubled it, a little bit less than doubled the ratio. So you've got, that's how you get that higher, you know, high 20s ratio. So that's kind of the mathy science behind it. And that's how it works. So it's pretty cool. It's kind of an awesome idea. And I'll tell you, when we install this, I'm going to show you, you can really feel it. You can feel it going really fast. So it's kind of cool. So I have all these calculations, and I'm trying to figure out what I want to do. I don't know if you can put Excel up on the description of the YouTube channel, but I'll figure out a way to get this available, or I'll just publish, you know, what I came up with. So I might be off plus or minus 5. So it could be like 25 to 1 versus what I came up with here, 30 to 1 at the peak. But that's just because, like I said, I think my calipers weren't measuring the grooves perfectly accurately. But to be honest with you, I can't tell the difference between 25 and 30. It's, you know what I mean? It gives you just a good idea of what you're getting. The lowest ratio possible with using the largest groove on the pulley and the largest groove on the drive wheel. Using the high-speed head is, according to my calculations, somewhere around 12 to 1. Still pretty fast, but I could make a nice sport weight with 12 to 1. Because I was trying to think if you could take this and actually just use it as a spinning wheel to make DK sport weight kind of yarn that I like to make. 12 to 1 is a little on the high side. I don't usually do it that fast, but still gives you those options. So I want to talk to you about the parts of the high-speed head. It's important because number one is some of these are parts that that are replaceable, and also just to make sure you're getting everything that you're supposed to be getting. Hopefully you order this from me, but if you don't, this will help you understand and make sure that you're getting all the tools that go with the high-speed head. When you order your high-speed head and it comes in, it's going to be wrapped in bubble wrap and cellophane. That's the way Majacraft is packaging it. And it comes with this standard fine flyer. I do have the option of not having the flyer. So if you wanted to just get the head, let's say you've got a couple other Majacraft wheels and this is just really unnecessary, you can get it. I can set it up to get you set up without it, and I'll make that listing and I'll put it in the description here. I will say it is kind of nice to have it just with it, because when you take it off, you can take off the whole system. But I get it if you want, you want to just sort of economize or whatever. So it comes with the standard fine flyer. The standard fine flyer has open cup hooks on either side in case you want to do a lace path, extend your the distance between the orifice and when it's wound onto the bobbin. So this just gives you more places to add and even out the twist. So they're open cup hooks on either side. These are not closed ceramic lined, it's open. And then you have the 8mm hook, which, I've seen people, this is the new thing they have. It's more like a handle, so it's easier for you to push to shift the hook up and down on the bar. There used to be a hook where the handle piece was just a straight up piece of metal, and it hurt when you were trying to shift it, so they changed it to this. I've seen people feed their fiber through it. It's not designed as a guide. In fact, it'll really slow down the ability of your flyer to wind onto the bobbin. You're going to still want to feed your fiber through this 8mm hook here. So that's what the flyer that comes with the Aura high-speed head. It's also the flyer that comes with the high-speed head on your Susie and your Rose. Also, as part of the assembly, now this comes all fully assembled, but I'm going to break it down for you. There is a high-speed head band. You can get this in the shop as a separate item if you need it. The little gem pulley, the high-speed head belt, the little gem. The idler pulley does not come as a separate thing, so if you break that, I can probably get you one, but I don't normally keep that in stock. Then it has this high-speed spring, so it's a very, very light tension. It's quite different from the standard spring that we get with our standard head. And it's just to give it ever so slight bobbin tension so that you can get those really, really fine lace weight yarns and not impact the inertia. The tension knob, there's a tension cord. I have replacement tension cord in the shop. One thing I'm just going to say about the cord is if it breaks and you need to reattach it, burn the ends, because it's a nylon woven cord and it will unwind. So just hit it with a flame to melt the ends and fuse it. And then there's a tension knob. I do carry the tension knob in my shop, and just so that you know, this is just fit in here. It's just pushed into the wood. So I have replacement tension knobs if anything should happen to this. So those are the parts of the high-speed head. So Aura users, one thing you're going to notice on your high-speed head is there's no black groove for your brake band. So on the Aura wheel, those of you that aren't familiar, the brake band controls your bobbin. So the bobbin is attached to a pulley and they work independently. That's what's the double drive. So you're not going to use this brake band because when you're using the high-speed head, you're using Scotch Tension. So there's no black line on your high-speed head for your bobbin band. And in fact, when you install your high-speed head, you can take the bobbin band, this black band, and just remove it. You can, undo the conrods, slip it out, and put the conrods back on. When I use it, I'm just setting it down here because I'm really just using it for demonstration. So I'm just going to gently set it on the ground while I'm doing this demonstration. The Aura high-speed head uses Scotch Tension. The Aura spinning wheel with its standard head is using double drive. So I want to talk about those two. They're really different. Double drive means, and I just took the band off, but it means that your flyer and your bobbin are both directly attached to the rotation of the drive wheel by their own separate pulleys. And there's a black band for the bobbin pulley, and then there's a green band for your flyer pulley. Both of them are controlled 1-to-1 ratio with the speed that you treadle. With Scotch Tension, the way that's working is the flyer is directly attached to the pulley, which is attached to the drive wheel, which is attached to the treadle. So those are all working together. You're directly controlling the direction and the speed of the flyer by your treadling because they're all 1-to-1 connected. The bobbin in Scotch Tension, and I shouldn't be pointing at this head because this is a double drive head. The Rose has Scotch Tension. The bobbin in Scotch Tension is being controlled by a tension cord, and that's this right here, and it goes around the groove in the bobbin. So as the bobbin is sitting on the flyer shaft, the spinning of the flyer causes the bobbin to spin also, and you can control that rate of spinning by the tension cord and the tension knob that is attached to the bobbin, very loosely attached to the bobbin. And the spring also plays a role in that. And so what happens is the flyer is going around the bobbin at a faster rate. The bobbin is spinning also, but not as fast as the flyer. So when the flyer is generating the twist, it's also wrapping around the bobbin. You want to use Scotch Tension for finer type of spinning, so that makes sense that it would be, they've adapted the high-speed head for the Aura to be Scotch Tension. The adjustments of the tension on the Scotch Tension are a lot more delicate, a lot more fine, and you're going to be adjusting as you fill the bobbin because the loaded bobbin causes a little bit of drag. So you're going to need to tighten up your tension in order to still be able to have the flyer spin around the bobbin faster. That makes sense. Double drive is more for art yarns, which is why Aura is considered to be the art yarn wheel, because it's you have the ability to set it up at the beginning, and because they're both directly controlled by the treadling and the drive wheel, you don't have to make adjustments mid-bobbin. It's also just, it's a better system for lower twist, lower ratios, a little bit grosser in terms of the control of the tension, so that's kind of where the double drive comes in. So like I said, when you're installing the high-speed head, you don't need to use the black drive band. So I just set it on the floor. It's still sort of in the circle, but I suppose if I were using the high-speed head or if I were going to take it somewhere, I would take the time and uninstall the conrod so I could slide the drive band off, but I'm not doing that, so I'm not going to deal with it. Okay, how do you install the high-speed head on your Aura? So I'm going to set this down for just one moment, because the first thing you have to do is uninstall your standard head from the Aura. I've already taken the black drive band, set it down on the floor, and now what I'm going to do is I'm going to treadle off my flyer. I'm going to hold on to the pulley that is directly attached to the flyer, loosen it to the left just ever so slightly, and then treadle it off. And I love to do it this way because when I try and do it by hand, I never know when I'm going to reach the end. It seems like it's taking forever, and then for some reason I fumble and drop it, and it puts a dig in my treadle. So I always like to treadle off the flyer. If you don't know how to do that, and like let's say you see me at a show or something, stop me and ask me to show you how to do that, because it's actually a pretty cool way to do it. All right, so we're just going to slide off the jumbo bobbin. Now, one thing I will say is when I'm installing the high-speed head and using it, really the best thing to do, the optimal thing if you're spinning lace weight, is to use a lace kit with the high-speed head. That's like your ultimate combo. But you can work with the standard bobbin. I wouldn't recommend using the jumbo bobbin with the high-speed head. It's going to be kind of jerky and not elegant, not even. So we're going to set the jumbo bobbin aside. So make a note of that. If you get the high-speed head and you don't have the standard size bobbins that are going to go with your standard fine flyer, you might want to order one or two of the standard size bobbin. All right, so next thing we do, I've already taken off the brake band. Now I'm going to just uninstall the drive band, which is just twang, do that. And then I'm going to take my 4mm Allen wrench that came in the toolkit with your Aura when you got your wheel. And if you don't have a 4mm Allen wrench, I do sell these in my shop, but you can also just go to your hardware store and get 4mm Allen wrenches. So I'm just going to loosen it. So like I said before, the head on the Aura is held on by this bolt washer situation here. So the head has a threaded insert that the bolt goes into. So I'm just going to remove this. I want to get it to the point where I can just do it by, So I'm also afraid of dropping a tool on my treadles. So the bolt that I'm unscrewing here does not, you don't get a bolt with each head. You use the same bolt. So if you were to use the overdrive, or the high-speed head, or the standard head, all three of them are going to use the same bolt. You don't get a separate bolt with your head. All right, so here we've got the standard head removed. Set the net aside. I'm going to take my high-speed head. So the high-speed head, just like the standard head, has got the two little bushings with the screws, and those sit inside of the head slot here. So, I mean, I guess you could, depending, I guess with this you can. With the standard Aura, you can't customize which side the flyer is on because you've got this gravity situation with the head flap for the tension on the brake band. But you can adjust, or you can decide which way you want your flyer and bobbin, if you want it on the right or the left, using the high-speed head, which is kind of cool. All right, so you stick those little plastic bushings in there, get the bolt lined up with the threaded insert on the head, and righty-tighty. Hand tight, you do not want to tighten it like as if you were tightening the grub screw on your pulley. Just a nice hand tight, just enough to make it secure, prevent it from falling down. Now, I'm going to install my bobbin. I'm going to probably set the direction wrong. I can never remember how to do this. So if I'm going to be spinning clockwise, there we go. I guess I just have to take a few minutes and take I already screwed up. So the first thing you're going to want to do, when your head comes in, it's going to, the tension cord is going to be wound up pretty tight. So you're going to probably do like 5 or 6 revolutions of your knob to get enough tension cord to be able to set it around the bobbin. I cross my tension cord, and when you cross the tension cord, make sure it's not touching. So like on this one, my tension cord is further to the back of the spring, so I'm going to put the one side closer to me, just so that the tension cord is not touching itself where it crosses. I need to loosen it up even more. They really tighten. That's just so it doesn't get tangled in shipping. Once you do it one time, you don't have to do it again. Okay, I always put my tension cord up on the top here. I don't like to have it touch the shaft because I feel like it's getting grease on it. All right, slide the bobbin on, easy peasy. And this bobbin, again, like I said, does not come with the head. So you'll have to source that separately. And I have all the bobbins. I've got the seafoam, the yellow, the pink, the blue, the black, the clear. They got all sorts of fun options. All right, so you're going to tighten the tension knob so that your cord is not, so that your spring isn't like drooping. And we're going to adjust this once we get spinning. So just set it like that for now. Now we're going to treadle on the flyer. This is the standard fine flyer. No, we're not. First, we're going to install the drive band. All right, so I'm going to take the green drive band and you're going to put it on one of the 3 grooves on the drive wheel. And then you're going to put the drive band on one of the 4 grooves on the pulley that's on your head. So you see you've got a 2-band situation. That's because you've got this, what did I call it? Gear chain? Gear train? Gear train. With 3 separate gears. All right, now I can treadle the flyer. Okay, now you hold on to the idler pulley when you're tightening your flyer. Now I'm going to feed my fiber through, and remember I'm not going to feed it through the handle part, these zigzaggy thing here, this flat surface is for you to use as a handle. It's not anything to feed the fiber through. The standard fine flyer has a closed ceramic orifice, so you need an orifice hook to get your fiber out of there. Okay, so let me just look at my chart that I made. I am on the smallest groove of the drive wheel, which has a diameter of about 12.5 inches, a little bit less, based on my very flawed measuring method. And then I have it on the largest groove on the pulley. And so that means that at this point, I will be spinning at a 12:1 ratio. So let's see what that feels like. Did I not bring any fiber? Oh, here's some. Okay. This is some alpaca that I got from a girl that came out to the farm to buy her Susie wheel. So that was nice. She left me with a bunch of fiber here. Yeah, that does not feel too crazy. I'm going to tighten my tension though, because I'm not getting any take up. And it's so incremental. It's like just a click of the tension knob. You can feel the tension increasing. So look at me here. I'm using my Aura high-speed head. Now, of course, as you know, the Aura with the high-speed head, but the Aura has that tilting feature, which now more than ever, if you're spinning lace, is nice to have a nice long drafting zone. Just incredibly cool. So that is our Aura high-speed head. I do have, I think I might have 5 of them in stock right now as of making of this video. And like I said, if you have an Aura, this really will blow it open in terms of things it can do. And if you're thinking about an Aura, adding this to your thought process, just gives you a lot more options and things that you can make. And my plan is to continue to carry the high-speed head for the Aura. So I'll be reordering as my inventory gets depleted. So thank you for stopping by to watch this video. I hope you enjoyed it, and I hope you could come back soon.